Gracias a todos. No sé si esto está encendido. Reanudamos la sesión. Las preguntas que se quedaron pendientes del primer panel, vamos a dejarlas para abrir.
For any questions that remained unanswered in the last session, we're going to wait until the end of this session to answer those. So I'm going to begin with the next round table that we've been calling decentralized footprints, and this has a lot to do with the fact that rivers
junto con muchos otros entornos rurales se han convertido en zonas de sacrificio, por lo que Paulette decía, el progreso este famoso que llega y hay que hacerle sitio y los demás somos los que nos tenemos que adaptar, ¿no? Entonces, muchas veces los efectos de este progreso o de este tipo de presión que llevan los ríos no se notan solamente con lo que es la cuenca o, vengamos a llamarle, el lecho del río, la zona de inundación, sino que muchas veces
flooding area as well. Often the expressions of nearby territories that don't form part of that river basin ask for and have different kinds of pressures. We've seen different consequences of the Green Revolution. We've seen the consequences of this on the river. The hydroelectric dams have also had consequences on the river, but now we're already in the third, fourth green revolution, and now we're into this digital revolution, and this continues to have a strong imprint on the land that we don't often talk about, or at least it's talked about by a minor elite. So what kind of role do the rivers play and the waters play in this new digital revolution? This is what we'll be discussing in the next round table with the following speakers. We are lucky enough to hear from three different perspectives. From the perspective of economics, as is the case of Jorge Bielsa, the industry as well, in the case of Abel Ortego, who's going to be talking about this more digital footprint, and in the case of devices there can be a more continued effect, and in this roundtable we're going to be talking about other kinds of pollutants or other impacts that are more difficult to trace, although traceability could be one of the paradigms of digitalization, for example in the case of water. So we have to look at how we can understand these more diffuse impacts, and we'll also be hearing from Óscar Pueyo, who is a geologist and also a neighbour. And so without further ado, I'd like to give the floor to Jorge. Can you hear me okay? Okay, well, I have around half a dozen slides to share, but first of all I'd like to begin by telling you why I'm here, or why I think that I'm here. I'm here to share an academic scientific study that we already published 4 years ago, and this is in a high-impact academic journal. And when I go to the meetings at the Ebro River Basin Authority, nobody ever mentions this study that we did. And I'm not making any complaints here, but there is an issue here. There's an issue of communication. The Ebro River Basin Authority should have some representative here as well, because I think, we're here to talk about the Ebro River. It's not the River Basin Authority of another river. So when we talk about these are online. These are things that have ended up in these academic journals of high impact, but I don't think that impact has reached us here. And we're talking here about the Ebro River. A lot of money has been spent, and this work that was submitted was done by a team of half a dozen researchers, Spanish and French researchers, who over a year and a half were studying nitrate pollution in the Ebro River. And we tried to design a system that would allow not just nature scientists to understand what was happening, but also so that economists and politicians as well could understand what was happening. We wanted to make a connection in turn between the more harder sciences and their political application in the everyday. This is what I want to convey to you today, more than the technicalities or specific points, which I do also have, and I have these prepared in an initial version of this presentation. I don't think that makes much sense. What I'm going to be talking about are the implications. I only have half a dozen slides to share. The title says basically everything that I'm going to be talking about. We have a problem, and that is nitrate pollution. We have a river, the Ebro River, and its tributaries, the river basin, as I mentioned here, which is contributing to that problem, that huge problem that we also haven't got under control, 100% under control in terms of data, in terms of future implications. This huge issue is reduced, minimized, and this is something which is happening silently, without anyone finding out about it, without it coming out in the news. This is what the news is doing. This is what the river is doing. It's doing so silently, and nobody really gives value to that. But we want to design a way in which to assess this. So when we go to present this, where there are many social scientists, the only kind of valuation that people understand is one that is an economic one in terms of money. You know, otherwise people are saying, yes, it's a problem, it's all words, it's a serious problem, we ought to act. But because we've been listening to this for 25 years now, perhaps now it's time to do things differently so that action is taken. And so, although Alfredo already mentioned this matter, the world still talks in dollars. It's the only language that the world understands. It's the only variable that you can get a reaction to, for better or for worse, but it does do something. If you don't speak to it in dollars, then the system says, oh, how nice. That's all it does. Communications, press releases, meetings, huge, long, beautiful sentences, but in the day-to-day, the delta, Ebro Delta downstream, you're not going to reach the heart of the system with words. You're going to have to reach the heart of the system in dollars. And so that's where we talk here about economists. And we have faced a lot of criticism by ecologists, logically, because they'll say, how can you reduce all of this to dollars? There's so many feelings involved in this. And I say, well, okay, but if we don't do that, then, you know, the opposite is going to happen. Somebody has to do the dirty work. And here you have me to do that. So, this is the system. This mentions basically everything. There is an idea, which we have heard so many times. I've heard it thousands of times. I don't even know who to quote for this first line. The quantity of water available depends on its quality. Quality and quantity are evidently related. And this is very important. In semi-arid areas such as our own, although these days people tend to forget that we're in a semi-arid area because we've seen rain recently, but in semi-arid areas this is even more serious. The solutions that RIN can adapt are completely different to those that we can find in the Ebro. This isn't the Mississippi, it's the Ebro, and that's the situation that we have. The first form of quantification isn't one that we have completed, and I will present that shortly, is how to measure this effect. And from more of an environmental, economic perspective, the first way to try to do this was through grey water, which was mentioned earlier on. Grey water is a way of measuring that connection between quality and quantity, and it's said that it's the quantity of water compromised as a result of pollution. That's the idea. And this gives us certain figures, certain numbers. We have something to hold on to. That's grey water. But we wanted to go to the next step here, which is our contribution. So how can we make sure that this grey water, that everyone has data on, and it's important, and it's worth fighting for a reduction in this, because in the end it's the level of pollution, but instead of measuring it in terms of tons of nitrates, this would be in terms of water compromised by those nitrates, which is basically a kind of complicated translation of what is done in practice, because it's easier said than done. So what we do is to assess this economically, and what we have is a possibility, and it's, why don't we do the following? Let's imagine that what the river is doing is something that we had to do ourselves with treatment plants. This would have its own costs. These high costs which are avoided, this is one of the techniques, and we have others, but this is one of the techniques that has been used to assess these environmental science services. We didn't invent this, obviously. We didn't invent grey water or the costs of services avoided. Obviously, you know, how much does one thing cost? Well, as a minimum, whatever it would cost us to do. I think that any judge of a court would say that it's reasonable legally to compensate nature with the cost that is avoided. I mean, it sounds quite good. It doesn't sound bad. This is the cost avoided. We're obviously not talking here about quantum physics, we're talking here about simpler matters, but so when we come down to the real situation here, we're talking about 8 people in a team who have been working over a year and a half, and of course you have to do specific things, and that's what we did. This is a diagram prepared by an economist of the river basin. This is the main river, the Ebro. Then we have the north tributary, the Gallego, the Cinca, and other ones. And then we have the south tributary, which would be a mix of all of those in the south that have less water for whatever reason the reason may be, because we have the Iberian system down here, we have the Pyrenees in the north. So these rivers contain a lot of information, but we only need, we only are searching for 2 data: the flow of the river and see the concentration of nitrates. With these 2 data, which fortunately today, well in this case in 2019, 2020 we had, so, and we didn't have that available to us in 2009, so this is a huge leap forward in terms of the availability of data. And then the second leap was that in 2009 we didn't have the IT capability to process that data either. This is a period in which the data at the Ebro River Basin Authority were only the daily flow data. And they said, here you go. And I said, what am I going to do with this? Why do I want this? To warm up. Those, you know, that paperwork they sent on didn't serve for anything for me. Although I would have been able to add them to the computer wouldn't have been able to process them in 1990. They wouldn't have been able to do that in 2000 either, but today they can. And today, at the Ebro River Basin Authority, you don't have to go to ask for the paperwork. They have a device which has come out in the media, and often, and it tells you the different river flows and different data, so you can process that. And you have computers that can process that data. So that's the difference between 2009 and now. So even if we had 200 people here, you know, that's the difference. The main work here was done by 2 people in terms of the data collection and data processing. And of course, in our disclaimer, each individual has put down which work they did. So grey water, which Hoekstra presented at the time in 2011, is a very simple concept. It just has 3 basic ideas. How many pollutants there are in terms of tons. Concentration per flow is X weight. If this were water, this would be tons of salt, as we did previously, and if it's nitrates, then nitrates, whatever the case may be. So this is the natural concentration here on the right, which is to try to think, because did the river at any point not carry anything? Well, that's not really the aim here either. So what is the natural volume here if we went far back in time? And this is a delicate topic here, because the maximum concentration would be something completely anthropogenic. Humankind might say, how much do you want to contribute? And so often it's mentioned that this is something, that the ecological flow of the Jordan, Cape Moses, and so on. No, it's something that occurred between human beings. And as there's no ecological flow, there's drought, then perhaps there's variability. But really, it's an agreement between human beings. It's not, Moses that's going to come here with the tables to tell us what the ecological flow is. So Cmax is the same. How much are we willing to withstand? Because if we want to know about the compromised amount, if we become very demanding here, then the maximum that we want to withstand here, even if we went 3,000 years into the past, we would already have this CNAT, but we already have this much. But how much can we withstand? And this here is the difference which determines the result. And this has been done, and this, we could have done this very quickly and we would have finished this study in 2 months, but we said, well, this has already been done. The only thing that we have done is apply this to the Ebro River, and that's it. Well, okay, we could have said, well, that's enough, we'll issue a few publications, and that's it. But we thought, we'll have to do something useful here, come on. So we said, well, if it also gets published, then even better. And this was the study that we did. I won't go into much detail, just as well I've got this on PDF, because usually I've got this as an animation and different things start appearing. But what I want to share here is the overall idea. When we ask what would happen if the river didn't do this, we have to simulate the river losing its flow. In 2019, this was a simulation. Within 3 or 4 years, this will be a reality. So climate change means that the river flow is reducing, and as this happens, it starts to reveal the concentration of pollution. There is part of the concentration of nitrates which isn't due to more nitrates being added to the river, rather because the water is reducing. This isn't quantum physics, as I said earlier. And so if this is the case, last year we got off free just by a tiny amount because of the nitrates, because we had huge rainfall. We saw the period of rainfall at the end of September, but things were very bad last year. I don't know if you were aware of that, because in the news this wasn't shared. So this is what we measure, and it seems simple. It's easier said than done. You'll be able to see that it's actually very complicated to carry this out. So we calculate this mass of pollutants, of contaminants, which the river is decontaminating for us for free, and we multiply this by the costs of treating that water. This is also involving a lot of work in terms of data for treatment plans, costs behind that, locating them as well. And then we get the value at the end. And here we have, if we're looking at the concentration that we have before the revolution, which was below the maximum flow, where the water was quite good. But this is also when we already had to decontaminate, even when the river flow wasn't reducing. Obviously, if it does reduce, then we have to decontaminate more. This is the paradox. As we decontaminate, we have to take out more nitrates, but with a lower volume of water to decontaminate, because in the end, well, this is nothing new. And here we have one of the muses of the drama. And this is a presentation that I, could have offered very simply. These involve just 4 ideas, but this is different. This consists of collecting all of the data from all of these different collection points. And this isn't the same as saying it. And then also the treatment plants, which are there at certain points, and also to have the costs in each of the areas. And this is the translation here. This is the jump where we can say that the red areas, which are the expected areas, this is the table of Europe that we mentioned earlier, and also in this river basin, but also because we have different kinds of agriculture going on. In the red areas, we're talking here about 33 and 42 million euros per year. And unfortunately, the Ebro River is not paying that. That's the idea, per year. This could be an underestimate. What's the most worrying part of this? What we see is what is flourishing. The measurements of the concentrations of the river is what is flourishing. But there's a procedure that my colleague will be talking about, who knows more about this. He knows more than I do. In that process, between the nitrates being shifted to another place and then coming out into the river flows, there in the midpoint we have this black screen. There are some studies, some estimates, but these have to be done in situ because we don't know what's going to be coming up. Next year we might see even more coming because they're from 2016. So the internal flow of these underground waters, which is where nitrate has to pass through. It doesn't go through the air, of course, it goes underground. We're talking here about water. And we don't know what's going to come out. So the analysis is what we've done with what we've measured, but as we've been doing the study, we were also aware that there were 8 million pigs putting nitrates into the water, and the data we were measuring were of pigs from 4, 5, 6 years ago, or even just a month ago. We didn't know, because even though we asked, nobody knew to tell us what the figure was, or any kind of sequence to be able to work temporarily on these matters. So this part of the study was left pending because we saw we were incapable of doing that. And this is what I wanted to present to you. Well, in terms of the conclusions, everything has already been mentioned. And we'll start from the beginning. Every time that the flow circulating reduces, there is an increase in costs. If that increase in costs is transmitted indirectly, immediately to all citizens, there would quickly be people saying, why is the river flow reducing? But because that increase in costs goes via nature, well, nobody knows where nature's current account is, and nobody is paying that current account, and so it withstands these costs. But in the end, there's a point where it might reach that account, but only in the very worst of the moments. So before that happens, let's see if we can convey, pass on those costs to it, or rather pay those costs to it, will say, well, at the moment we won't pay that into your account, but please know that that's going to reach you. That's the idea. Because in the last instance, these are the people that will vote for the others. These are the people that we have to explain. We have to say to them, don't worry, you're going to get this invoice. You might say, no, there's no data yet. It's climate change. You have to see whether this invoice interests you or not. But be careful, because this is a bill that will reach you. And this is the reason why we're here. Because the scientists of the journal where we published this article have already told us that this is good, but we're talking here about 10 people only. With 10 votes, we can't do much. And that's everything. Nothing else. Thank you.
I hope you can hear me well. Good morning, and especially thank you to the organizers for inviting me. Thank you as well to the previous speakers, because I really enjoyed listening to you and I greatly learned from you and from hearing you all. What am I doing here? Well, I am actually the Plan B, and why do I mean by that? My friend and thesis director Alicia Valero was invited, but she is a very busy woman, and she said, Abel, since you enjoy speaking in public, why don't you go? So here I am, and I will be trying to convey part of the knowledge of the research center that I belong to, and let's get started. When I was told I would need to make a presentation, one of the main topics of interest is what is happening with data centers. We are seeing the emergence of data centers. We always see them in the press as a positive thing. This will generate lots of thousands of jobs, but certain people, we do not trust progress, and we of course need to analyze what is happening with progress and what is behind this growth. We have all heard that data centers consume a lot of energy. They require big refrigeration systems for these data centers. I am not specialized in water, but I can talk about the impact of data centers and the location of those places where there is water. It is the same with the electricity plants. They need water, and the same happens with data centers. So I will be talking about the impact beyond. We will be talking about the resources needed for its construction. I will be sharing with you some data that are hard to collect. This growth of the data centers is having an exponential growth. This is something we already knew. There are more and more data centers, there is more data traffic, and of course they need to be built. These data centers are demanding resources such as energy. Here we can see this line where it says data center energy use. For example, in just 6 to 7 years, the energy consumption has grown by 40%. What does this mean worldwide? Well, the data centers that for us 1 decade ago were non-existent, now we would be talking that this represents a 3% of the electricity consumption, and the number is growing. Out of this 3%, 20% belongs to the crypto world, that dark world of the cryptocurrencies. Before, there were people who invested in seals, and now people are investing in cryptocurrencies. Well, good luck. That means 20%. It is a dark world, and it represents 20% of the energy consumption. I don't know if you have seen how these cryptocurrency centers work. There are some examples in the US, and they are quite interesting, to be honest. So here we can see the trends about the growth. Now, a couple of things. In the world of IT, during the 20th century, there was a law, namely the Moore Law by the 50s. According to this author, every 2 years, the number of transistors was duplicating. That is, a microprocessor was needing a greater number of transistors. And now, the current data centers rather apply the second law, the Kume law. What is happening is that processors are more and more efficient. That is, energy efficiency of the chips is duplicating every 2 years. Of course, data centers are more and more efficient. The amount of kilowatts per hour by storage unit is lower. But before, a colleague was talking about the Demon's paradox. And I said, that's great, because I also wanted to mention this paradox. What happens when there is an increase of efficiency? Well, usually there is a rebound effect, which means an increase of the consumption. For example, when we have to pay for less fuel, then the consumption and the demand increases. This efficiency increase entails a dark side. Usually, efficiency is a synonym of an increase in the resources used. And why? What do I mean by this? Well, if we ask ourselves, what is a data center made of? There are big processors, and you will remember some years ago when we were in the pandemic, there was a supply crisis, and one of the first things we heard about was the word semiconductors. That was in the middle of our conversations. There was a crisis, and why did we need these devices? Well, because chips and processors needed to be built. And where are the semiconductor mines? Where is the supermarket? Well, in this periodic table, we can see different elements that are more or less needed. There are 20. Some of them are really scarce. For example, semiconductors, refractariums. And when we are building a data center in a certain place, well, of course, that data center will need a certain amount of resources that come from different places. And we also need to take into account its impact. I remember an article I published. It was a dissemination article, and perhaps some people have read it. So it was an article talking about what happens with the rare soils that are used for the electric engines. And we can ask ourselves, where is the mine of the rare earth elements? This is in China, in a specific region, Guayabon. And we can think that, of course, the Chinese authorities are doing a good management of these mineries so that we can have an electric vehicle, and we feel that we are saving the planet. But we need to be careful. Of course, the extraction also implies radioactive elements. This filtrates into the aquifers, and sometimes we do not think about the impact of what we do, and we can even find the paradox of doing something that we think it's going to save the planet. Oh, I'm a great person, I have a Tesla, I have solar panels in my roof, but perhaps that's not that good because there is an impact behind it. If we extrapolate all of this to the data centers, we have all seen this with our cell phones. We are going towards a small size. And what happens with the small size? Well, that it cannot be rightly recycled. If you're an optimist, you could tell me, no, everything can be recycled, but we need to be careful with this sentence. It is not the same to cycle something rather than to turn things to the origin phase. Jorge was talking about the costs, and that it's what happens when you are cycling something. You are not living it up to the ideal phase. When a paper is recycled, the result will have a worse quality, and this is something that we need to take into account. Many people can say lots of phones are recycled, but I will ask you, where are your old cell phones? That's the question I am asking you now. You keep them just in case, right? This happens. We all know about it. And we need to remind ourselves that recycling entails certain rules and regulations. Before I was saying that data centers has 20 different types of metals. A car would be with 50 elements. But of course, when we recycle, there is no specific recycling plant for the different elements. For example, manganese, etc., etc. This goes to big recycling plants. And if you are going to, for example, fragment iron, what will happen? Well, everything that is mixed with iron in the alloy, for example, with copper, etc., this cannot be recycled in metallurgy because this will create some slag. For example, with a car, when this goes to a recycling center and it is taken to a siderurgy, the tactile screen has been fragmented and has been mixed with the other elements, and therefore the different elements such as tin, engine, etc., the elements that are needed for this tactile screen, what does it happen? Well, they get disseminated. So this is what happens with these small devices. It is more and more difficult to recycle them. My colleague made a mention to rice. It is like, you know, if you are eating a paella and you try to get to taste the saffron, it is impossible because it has already been mixed with the rice and with the rest of the elements. Here we can find some numbers, and there is a paradox because the most energy efficient technologies, for example, a LED is more efficient than a bulb, but from the point of view of the materials that are needed, those are more inefficient, and the same happens with data centers. Perhaps someone positive about technology say this is more and more efficient. Yes, but we need more and more resources. This is a graphic. This has nothing to do with the Ebro River, but here we can see the evolution of cars along history. Yes, we can see that cars are more and more efficient, but the amount of materials needed for its manufacturing are exponentially growing, and this is very similar to the previous graph that Jorge showed us. What do I mean by this? Before, I was saying that we need to be careful with this trend. There is another side of the coin with these materials, and the same happens with data centers. In data centers, obviously, we need PCBs. Alicia wanted to make a comparison. I found it risky, but it was really interesting. And she said, in the end, metals can be found in the minerals that are present in the mines. A mine is called a mine because obviously there is a high concentration compared to the amount of mineral that you want to exploit. And she was saying the mines with a greater amount of gold have 8 to 10 grams per ton. That means I need to process 1 ton of that land in order to obtain 8 to 10 grams of gold. That's what happens, and that's why the mines do such drills and big holes. This will, of course, depend on the concentration of PCB, but in the case of PCBs, this would be 860 grams per ton. This is a greater number. We can find more gold in a PCB than in a mine. However, the difficulty of extracting that gold is greater. And why don't we do it? Well, because technologically wise, this is not easy. When the alloys are made, we cannot extract those separate elements. Before I was explaining the exponential evolution of data centers, and here we can see the exponential extraction of raw materials. This has exponentially grown, not only in amount, but also in variety. And the mines are finite. And what does it mean? Well, it means that the amount of land that you need to move in order to obtain 1 unit of the material that you want to find is greater and greater. And here we can see these graphs. They are complex, but the bottom line is how, along the years, different types of materials have changed in the concentrations. What happens with mines? Well, the concentration in the mines is lowering. We have data centers, we have digitalization, and those are predators of those kind of materials. Before, we were talking about the avoided costs and the mines. Which is the value of a mine? How can I measure it? Well, the fact of having concentrated minerals in a mine, when we are exploiting them, what we are doing is taking something from nature, something that nature has generated for millions of years. Here we can see the example of copper, gold, and zinc. And thanks to economists, we could translate this into euros. What happens when mines get depleted? Well, the concentrations decrease. The energy that we need is also greater. The same happens with oil. They are going to obtain the last drop of oil. No, but there will come a time when the extraction of oil will be more costly because the techniques will be more sophisticated and complex. And the same happens with mines. The energy costs multiply. And even if they create a data center and they say that they have created some photovoltaic parks, and that's, of course, that's great press, but the machinery working in those centers is not machinery having a solar plant, right? So we need to remember that this machinery works with fossil fuels, and actually 10% of the CO2 emissions worldwide come from minery, and this is something that needs to be taken into account. And data centers consume a lot of materials. This means minery that is needed. And when it comes to water usage and pollution, this is something that requires a lot of water. In Spain, big catastrophes have been made due to this resources usage. And now I will be finishing very soon. I was talking about the limits. There are limits, of course. Now we are already talking about where there will be enough lithium for everyone and cobalt. Well, if I invite Carlos and Jorge and someone else to eat at my table, perhaps I will have something. But if I invite you all, of course, there won't be lunch for everyone. This is a clear thing when it comes to offer and demand. Recycling has many limits. We need to remind ourselves of the aerodynamics rules. And what doesn't happen? Well, some studies give us certain numbers, and they say, well, we could have supply issues with lithium in 2050 or 2060. And some people may think, oh, 2060 is far away. This won't happen to me. My oldest son is 9 years old, and I was watching with him the series of Once Upon a Time, and it said 1 million years ago, and oftentimes we forget that the history of humanity is almost nothing. And some people say, oh no, there will be lithium up until 2050. You don't need to worry. But we need to remember that the ecological disaster from the 20th century It was huge. If that had happened in the 19th century, we wouldn't even be here. And now, to finish up, we can ask ourselves where a data center will be recycled. The data center has a very short life cycle because the systems are constantly renewed. In this case, we can see everything that is in the market. This was a study that was published in a magazine. And out of these things that are in the market, we can see a big amount in stock. But there is a very high amount of the non-collected materials. And within the non-collected, the most recycled material is aluminum. They talk about data centers, semiconductors, everything is recycled. Yes, but what do you pick up from it? Do you take the saffron from the paella? Well, quality and quantity is not the same. And in the recycled world, this happens. Oftentimes we talk about quantities, but not about quality. So those were the messages that I wanted to convey. I wanted you to know what is happening with these new infrastructures that are being built. There are impacts that we do not see, impacts that go beyond the natural side. This also affects the social side. We could also be talking about the social injustices in many African regions because young people are working in the mines. And then in Europe, we are saying that we are saving the planet by buying electric vehicles, right?
Sí. Vale. Pues yo lo había mandado ayer, pero que no llegó, o no llegaría donde fuera.
I sent this presentation, but perhaps you didn't get it.
Pues ya casi iba a decir buenas tardes, pero todavía no.
I was going to say good afternoon, but
antes de nada, agradecer
it's not still time to say good afternoon. Well, first of all, thank you to Carlos and Asun. Thank you very much for inviting me to participate in today's session.
Me aguantaron una hora y pico hablando de un montón de cosas.
I was talking for an hour
y cuando terminó, me
about lots of things, and when I finished, they say, why don't you talk about this? I didn't know what I had been talking about. I had been talking about lots of things.
Creo que tiene que ver lo que vamos a plantear o lo que voy a plantear con lo que vamos a hacer esta tarde. Voy a
Anyway, what I will be talking about will be related to what we will cover in the afternoon. I will mention some ideas from my colleagues, some references to the million of years as a geologist, and I will tell you a little story because it's what I would be doing with my students in class. And later on, I will explain what I am going to explain. Perhaps you won't really understand in the beginning, but please bear with me. This morning, Alfredo was talking about the river, the floodings, the terrace, and how this system is related to the sea level and how we can increase and decrease the sea level to retrograde if there is any subsidence, etc. And everything related to this balance in a natural world, some millions ago, there was no human intervention in the system, right? I said I would be using some naive paintings. Those are the images I use with my students. So we have this system with a river. It could be the Ebro River. And here it doesn't really matter what these images represent, because I will go beyond this. Perhaps the geomorphologists from the Ebro River will be talking about the details. This is irrelevant right now. And okay, let's say we have a flooding. The water level increases, and here we can see an increase of the affected area by these waters. This morning we were told how important it is to reduce the energy in the middle, this energy of the water is dissipated, and for example, when there is a flooding, the cars are tracked if the floodings are exponential, and this is something that the colleagues also mentioned previously. What does this mean? Well, this could be a town such as Remolinos or Alcalá de Ebro. I think that's what you visited yesterday together with two geologists. And here we can see a town, the urban area, and we do not know what's there. If we had to make an urban planning for the future, perhaps we could think of building somewhere else or change the location of the building. So let's say this area is affected by the flooding when there is an increase of the water level. We could create a certain wall, we protect the town center, and if there is a flooding or an increase, the water cannot enter this area, because the town center is protected and there is a wall that is protecting this town center. This could be a happy idea of living along the river. So the solution could be simple. We put walls everywhere, and that's how we protect everything. The roads, the train station, the reservoirs, because they are important, and therefore we build all these walls. And this, of course, entails a change and a modification in the river flow, because we are reducing the section of the river, and this is something that is accumulative. I have certain issues in the river basin, but if I see the waters up in La Rioja, we can see that the action plans in that area will affect our areas as well. The same happened in Zaragoza when they thought of dredging the river, but then they thought, perhaps we can forget about the stone bridge, right? So, of course, all these action plans can generate certain issues. The barrier that previously allowed our town center not to be flooded, well, now this has been reduced and we have a problem which we didn't have before. We are trying to solve little by little what comes up, but what we are actually doing is creating more problems in the future. So the idea was that we were protecting our town in the beginning, but now we cannot protect it anymore because everything is flooded. We are here. With the star, we have the Ranillas meander, the Expo from 2008. We have the different terrace levels. In the case of Zaragoza, the distribution is asymmetric. In the north, we can see Juslibol, the Ebro escarpment, the confluence of the three rivers, and this is the situation where we find ourselves. Well, since we are here, Carlos was saying, I am a geologist and a neighbor. Well, here we have a citizen science project. We have made some activities with this organization, and we are assessing the floodability area. We are thinking of the likelihood based on the flows and the limitations. What what is the flow that we will be using. The context is different. Now we have different volumes. Alfredo was saying before that the floodings can be prolonged over time, but we can end up saying what is obvious from a geological point of view. This can be flooded, and then we will see about the likelihood. This also has to do with what Jorge mentioned before, which are the thresholds that we want to think about when making the calculations. Of course, we will be affected, but we also need to think how this can be made in the long term.
Obviously, different things happen. This is Plaza Europa. I'm not sure if you've seen this as you came over here. This is in the center of Zaragoza. Here we have the Almazara Bridge, the neighborhood behind. We have the park here as well. And suddenly we have to excavate, we have to make a barrier, and this water starts to rise up. Here we have the Ebro River flow at the top here in 2018. 1,120 meters cubic. And these are the extraordinary situations that we have, and we could perhaps also discuss what that means if this happens every 3 years or so on. You know, this is what the data says. Once the maximum floods of the last 10 years are exceeded, well, statistically in the last 3 years we have 3 above, 3 below, 3 on average. So it turns out that the water appears here, and we have this overflow at the moment. However, we don't need the river to overflow for this water to appear. And here we have one of the streets around this Plaza Europa. The water appears in the soil. We have this ditch.
Creo que se llama calle Río algo, no me acuerdo si es Guatifalema o es Guadalupe.
This street is called Calle Rio something, I forget which. So what we have to think about in terms of my very simplistic drawings here, we have the river here, the Ebro River, for example, and then here we have the different gravel areas. This is the phreatic level that we see sometimes, the water table. And so here we have the current level with all of the different areas where the rocks are placed with the water in between. So we have this intersection, so we're talking about a line, but when we're talking in 3D, we're talking about a surface area which is full of water. So what happens then? When the river level rises, we see an increase in the level of water, and this happens throughout the whole area. It happens along the whole river area. Those of us who live in the Almazara area know that the day after the river flooding, when we hear about that in the news, you know, tomorrow at 3 o'clock, it's going to reach us. I don't know if you're from here, but that tends to be the news that we hear in the press. We know that it's going to come a time after that. I live right next to this building. My building has 2 basements, and when there's a flood, then we see flooding in our basement. And this has to do with the levels of water rising in the underground. So Etopia would be around here, in the very limit before we head up to Avenida Soria. So in the terracing areas and the areas around the river, the position of the water table, the position where all of the sediment is full of water, if you look at the topography, it's not really a horizontal line, it starts to creep up. Paco or Alfredo might start to criticize me when I start to talk about how the river flows. But this is what the surface area looks like. If we do any kind of survey along this whole area of the neighborhood, we would find the water table associated to the river Ebro. If we see flooding and the water level rises, what happens then is that sometimes the topography intersects the water table and the water then appears. So this isn't so much to do with river relations, it's more to do with aquifer relations. And I'm saying this because this was the idea of today's presentation, to propose that The river has a different dynamic. The water goes much faster. However, the volume of water associated to the river is much greater throughout this whole area that we're in now. And when we have to look at the problem of looking after the river, we don't just have to think about looking after the bed, we have to also think about looking after the underground water as well. And there's one condition of the water table that we have in this area. And I'm just mentioning this in general. What this means is that in this diagram that I mentioned earlier of building a wall to protect the town, when the flood comes along, the water doesn't enter the town, but the water table does increase. And so we are seeing that increasing even though the flood doesn't reach the town. So this is something that Alfredo is actually working on in the project that we're doing, where there's not just flooding because of the river overflowing, but also because of this increase in the water table and seeing water coming up in other areas. And what this means for the built environment and so on. The rainfall that we saw several days ago here in Zaragoza, which led to different peaks in different areas, has to do with the filtration of the water superficially through the asphalt. This is a news item that came out in the Heraldo de Aragón, which quantified the volume of water associated with the aquifer of the Ebro in Zaragoza in 274 cubic meters. If we're talking about cubic meters per second, that's a difficult way of looking at it because we're talking about flow and so on. We're talking about huge volumes of water compared to what we see on the riverbed. Everything that Alfredo mentioned, the care and the precaution that we have to take there, but this superficial riverbed, these huge volumes of water affect the river and they affect the aquifer, or the reverse. Everything that affects the aquifer ends up having a result on the river as well. And as Jorge mentioned earlier, we don't know where the pollutants are that are getting into the river. They get to the river at some point, and when we were having our coffee earlier on, we were talking about the issue of the water tanks. We have, we flush the toilet, whatever, but everything appears somewhere. So we have to look at this perspective of what is the system. As was mentioned earlier, this idea of, what is a management system of the Ebro River Basin. So what is polluted upstream in Logroño will also come into the riverbed. And as Jorge mentioned earlier as well, we're looking at different thresholds of decomposition that we're going to be working with, or that we're going to be considering anomalous or that have to be worked on. A few months ago, we proposed a roundtable on these items, and there was a meeting at the Ebro River Basin Authority, and something that we talked about was that unit of 50 that we hear about all the time in terms of the thresholds for nitrates and so on. Where does that value come from? And the answer was that they weren't very clear on whether it was a scientific value when it came to assessing it. It was just something that was traditionally used. Essentially, it allows us to compare that there is a number greater than what I found, but we don't know if this affects health, if it affects the environment. There are many counterintuitive things going on. We know that there are many algae in Zaragoza. We have the problems there with the specific black fly and other issues, but there's a time where we have to look at what's happening in the rivers. We have the eutrophication of the rivers. And often this has a lot to do with what's going on in the aquifer. The website of the Ebro River Basin Authority that produced this graph here, this diagram, looks at the different river flows in the Ebro River Basin area. This isn't the problem though, and I think that this is something that we have to discuss. This is the issue here. We're not talking here about river flows, we're talking about areas where the aquifers are affected by this change in the concentration of water, and where we are seeing underground waters, aquifers that are being affected by nitrate levels. This is something that is very much being spoken about a lot in terms of agriculture, the number of pig farming areas that we have in our region, and their efficient management or not. And beforehand we talked about having a vice presidency in the government in terms of water, and I think that we do have to find a way to manage the water that is efficient for the whole area, because it's not just a matter of, looking at what's happening locally. Really, everything that happens at one place affects the other, and the administration of the riverbeds has to be done properly. I'm talking here about the Ebro, of course, and we have different surface areas that are affected with this threshold of 50 that we're all very much aware of. We've seen a concentration of nitrate per litre of water in the riverbed, and we have areas here where we have concentrations above that. So is the value of 50 good or bad? Well, it's a value that has been put there, and it helps us to assess the situation. If there is more or less, doesn't really help us to know what the situation, if it's better or worse. But of course, there are other metals which are accumulative, which have a more prolonged period of activity, that have actions on the body and so on. And so this is a matter of health. We talk about thresholds so that we can compare how the river is acting. So now we have more metals coming in, and we have to compare whether the system has been changing or the environment has been changing. So here, if we have a volume of water with a certain concentration of pollutants or whatever, and if we join that together, then we have these two masses of water, two rivers, that end up joining, and they generate a volume of water which has the same concentration that it had at origin. We haven't changed the problem, in other words. What happens other times is that we have huge rainfall, as Jorge mentioned, and then suddenly these are extreme periods of rainfall, and then suddenly it feels like there's no problem. Suddenly the concentration has lowered, there is a lower number of litres, but these elements are still there at the centre. And underground there are biological processes that suddenly might remove some of those pollutants because of the biology in the aquifer, or because the concentrations are higher in the surface area. It's not a case of just because the concentration is lower, there's no problem. It's the same that happens in mining. They're looking for a concentration that is more economically profitable. So there are many different changes in concentration. My idea was to show you that the fact that we're not going over the threshold doesn't mean that we're not encountering any issues. We still are, but it's more diluted, that's all. The contamination is still there, the pollution is still there. And I'm telling you all this because I'm going to talk about my neighbourhood. I said I would talk about my neighbourhood. I'm going to talk to you about some wells that we have in the network for monitoring the underground water in the Ebro River Basin Authority. One of these is at the Plaza Europa. Here we have some that are more red or green in colour, that have a pH of 2 and above. And here, why is it that in this neighbourhood, the Almozara neighbourhood, which was also known as the chemical neighbourhood, it was known as that because we had all the chemical industry here, and that's why in the underground water we have different pHs. We've seen arsenic, we have seen lead. There are huge amounts of metal that don't generate any issues because the mass of water contaminated is small, and when that reaches the Ebro, it's diluted. However, we're evaluating a concentration of metals that we're putting into the river, and we don't know where it's going through, what concentration it's going to cause in other areas, the concentration of iron in residues. To talk a bit about mining, we're looking at
de espesores de entre 5 y 8 metros en
weights of
el barrio
between
de estos
8 and
residuos que
10
vienen de la
meters,
aportación
5 and
de
10
sulfuro
meters in the
para sacar ácido
region
sulfúrico que se utilizaba para las baterías de
for
vapor que
sulfuric
estaban aquí.
acid, for example, that we use to create batteries just not far from here. So this is me telling a bit about my background and my area, and in the end, everything that we flush away ends up in the river. And we have to also think about what is behind all of that, what hidden materials are there. To assess the excess nitrogen that we have per area of land. Up until recently, we didn't have any issues with the nitrates in the pig farms because we use slurry for agricultural use, but that material which is contributing to agriculture ends up in the water table, and we don't know where that will end up. So the management that is being done by administration is, when we're looking at these kinds of farms, perhaps this should be done in a more holistic way, thinking of the whole of the river Ebro and the matters that end up in the Ebro River and change its composition. If we look at the satellite imaging of the methane in our environment, I'm finishing up now. We can see where the issues are coming from, where these contributions are coming from. However, it's not just in these areas, but we have this riverbed where we have a series of different entrance points into the system that are migrating. Going back to the topic, it's not so much the importance of the management of the elements in the riverbed, rather we have to have a vision of the system which we proposed at the beginning, which is more holistic, of the whole riverbed, because wherever it is generated along that, the problems end up arising. This is a diagram that I talk of about danger, exposure and vulnerability equals the risk. When we want to evaluate the risk or the feasibility of a system, we have to think about the exposure, looking at the process and the concentration of metals and so on. As Jorge mentioned at the beginning, in terms of the limitation of the accessibility of water, the volume of water that we have beforehand was much greater than what we have now, and the effect of the meteors and so on. So we have this limitation as well, which has to be taken into account. And now I'm going to be finishing up. I'm just going to refer to Javier San-Román, who's from the Ebro River Basin Authority, who gave a speech to the University of Zaragoza about the diffuse pollution of water by agro-livestock farming activity, and this is actually on our website, and I'd like to offer this to you as an example. And many of the things that I've discussed have to do with this leaflet that we produced a few years ago about living in the region of La Almozara, this neighbourhood, and it's to define the context that we're seeing here, the situation that we have here, to understand the problem and to understand, well, although Carlos is going to get annoyed with me, this afternoon we're actually going on an outing within the night of the researchers along the Ebro riverbed within the Almozara neighbourhood. We're going to be taking water samples and analysing them, and we're thinking about taking water from the river, from the aquifers, to understand that water has history, and it's to look at this content of contaminants or dissolved elements, which has to do with nature as well. A river comes through this area which has hard water, and also we have a lot of water coming from the Imperial Canal, which comes from Tudela. So the issue is that the water doesn't so much have the problem of hard water, but also we have to look at this idea of, well, this outing this afternoon. But as this coincides with other events happening this afternoon, then perhaps we could do this on another day as well. So thank you very much.
Bueno, pues nada, con esto terminamos.
Well, this is the end of the first session. We were a little bit delayed this morning, just, well, things that happen. And we will do a Q&A session in the afternoon after the third panel, okay? And so, after all, in the afternoon session, we will make the Q&A sessions, we will discuss the different questions, alternatives, and now we will have a lunch because we need our batteries to be fully charged, and we will be back at 3. Okay, thank you very much.